Let's talk about correlation analysis in this video. Terms do not exist alone. Sometimes in a text dataset, we do want to analyze the relationship between terms. In the previous lesson, I talked about n-gram analysis. For example, when we create the tidy text format, we can put either two terms as one token or three terms as one token in each row. This is called the n-gram analysis. But the n-gram analysis is facing a limitation. This analysis can only analyze terms adjacent to each other. So when we split terms into tidy text formats, we can only separate terms adjacent to each other. This is a major limitation of n-gram analysis. So what should we do? We developed the phi coefficient analysis to address this issue. This table shows you how you calculate the phi coefficient. In this table, you see a lot of little n, right? This n represents the number of documents that contains certain terms. For example, n11 represents the number of documents that contain both term x and term y. n00 represents the number of documents that do not contain either term x or term y. So after you identify all the number of documents that qualify certain criteria, you can use the equation on this slide to calculate the phi coefficient. This coefficient indicates a probability. The probability that term x will appear in a document along with term y. By doing this, we can identify the correlation between term x and term y. Notice that the most important key feature of a phi coefficient analysis is we do not need the term to be adjacent to each other. So this addresses the issue of n-gram analysis. Let me repeat. Phi coefficient analysis does not require the terms to be analyzed to be adjacent to each other. This gives us a lot of flexibility when we analyze the relationship between two terms. Fortunately, we do not need to calculate phi coefficient by hand. We can use a function from the YDR package. The function is called a pairwise core. Core represents correlation. So let me show you how you perform this analysis in RStudio. I listed this code under this video. You can download it onto your RStudio and try it out at home. So here I want to explain the purpose of the code. First, you want to install and use a library function to start the following packages. As you can see, I use ggplot2, igraph, and ggraph. The reason is I want to visualize the correlation between terms so that the data users can see the relationship more clear. That's why I use ggplot2, igraph, and ggraph. Next, I want to import the original dataset into RStudio and then transform the dataset into tidy text format. Also, I showed you an example about how to process stop words. We want to remove stop words such as off, on, in. Those words do not give us lots of meaningful relationship, so we want to remove them. Next, I want to expand the stop words library. I want to remove HTML text. So this is the purpose of this code. In case I have HTML text in the original dataset, I will also treat them as stop words and remove them. Next, you see I use the pairwise core function to calculate the correlation between each word. And finally, I want to visualize the terms with a high-phi correlation coefficient. Here you can set up the minimum correlation coefficient. In this case, I set 0.5 as the minimum. You can change the number. You can change to maybe 0.6, 0.3. You decide. Of course, every time when you change the minimum correlation coefficient, the final result will be different. So let's try 0.5 as an example. Once you execute this code, you should be able to see a chart like this one. The edges between terms represent the strength of the correlation. The thicker the edges are, the more correlated the terms are. As you can see, we have a cluster on the right side of the chart. They are highly correlated. For example, United and States are highly correlated. Why is that? Because every time when we mention the US, we usually mention it as the United States. That's why United and States are frequently appear together in the same document, of course, right? What about America? Sometimes when we mention the states, we'll mention it as the United States of America. That's why America is highly correlated to United and States. In addition to this common knowledge, we can see something interesting as well. For example, Security Exchange Commission are highly correlated to the United States of America. What does this mean? Because this dataset is about SEC's legal action towards cryptocurrency violations, the SEC actually represents Security Exchange Commission. That's why when an article mentions this organization, it will usually mention it as the United States of America Security Exchange Commission. That's why these terms frequently appear together. They are highly correlated. In addition to this organization name, we can also see something like 1934 and the term Act. What does this mean? If you do a Google search, you will find that the US government created an act, a legal act, in 1934 to prevent security fraud and protect investors. And the government gives this responsibility to the SEC. So this shows you the purpose of SEC. This also shows you how you can use text mining to gain more knowledge about a dataset. And then we have another correlation between ICO and the issuer. This shows that the SEC's legal actions are most toward the ICO issuers. ICO and issuers are frequently appear in the same document in the dataset.